Number 6, starting where x is, the first thing I did was add 6, then I took the square root, then I multiplied by -2, then I subtracted 2. So the inverse, I'm going to start by undoing the subtraction. So I add 2. I'm going to divide by -2. Going to square and subtract 6. So I'm going to write that. I'm going to say x plus 2. I'm going to divide that by -2. Square and subtract 6. But when I square a negative, that becomes a positive. On number 7, I've been asked this several times. The signs, there's a lot of negative signs. You're trying to figure out if they're negative or actually a minus sign. The first 2 are indeed negative signs. The last 2 are minus signs. So this quadrant is 1. This is quadrant 2. This is quadrant 3. And this is quadrant 4. It goes counterclockwise. I do believe this is quadrant 1 because x and y are both positive. So when you graph this, this is actually, I do believe, in quadrant 3, but we can look at the graph. When you put this in, make sure that you're arrowing out of the square root, and then -2. Oops. -2. Yes, this is in the third quadrant. So we can find some points. And plot it. So I have -7, -4. -4, -3. And -3, -2. It's in the third quadrant. So number 8, I'm given a table and I'm asked to find the equation that matches the table. So I want my equation in the form y equals a times the square root of x minus h plus k, where hk is the first point in the table, and a is the difference in my y values. So the difference in my y values, here I'm increasing by 1 each time. The difference is 1, the difference is 1. So here a is 1. So there's no stretching, no compressing. So then my hk is -2, -7. So when I write it, it's y equals the square root of x plus 2 minus 7. It says subtract h. If h is negative, I'm subtracting a negative, it becomes a positive. For all you skeptics out there, put the equation in, look at the table. -2 should give me -7, -1 should give me -6, and 2 should give me -5. So it works. Number 9 is the same. I want it in the form y equals a times x minus h plus k. So here h is -5, k is 1. And the difference in my y values is -2. So I had a reflection and a vertical stretch by 2. I didn't ask you to find the transformations, but I want you to be able to connect the transformations with a table, not just a graph and an equation. So I have y equals -2 times the square root of x plus 5 plus 1. So number 10, I need to isolate my square root. So here I'm adding -6 to it, which is the same thing as subtracting 6. So I'm going to add 6 to both sides to isolate my square root. So now I have the square root equal to a number. So that's my first step. My second step is going to be square both sides. So if I square both sides, I'm going to get rid of my square root. These two undo each other, so I'm going to be left with 7x plus 1 equals 36. And then that leaves me my last step. collect like terms. It's just kind of the general process of solving these by hand. So here, I'm going to subtract 1 to get all my constants together on one side. So that leaves me 7x equals 35. So now I can solve for x by dividing by 7. So it leaves me x equals 5. If I put 5 in here, that would tell me 7 times 5 is 35. 35 plus 1 is 36. The square root of 36 is 6. Negative 6 plus 6 is 0. So this one does work out. The next one, my square root is already isolated. So I can go ahead and square both sides. Leaves me 9 equals 1 minus 2x. So now I can collect my like terms and solve for x. And subtract 1, it gives me 8 equals negative 2x. So I'm going to divide by negative 2. And that gives me x is negative 4. So I put negative 4 in here. I have 1 minus 8. Well, negative 8. So it would be 1 plus 8. That's 9. The square root of 9 is 3. So 3 equals 3. So x equals negative 4 does work out. Problems like 12 and 13 can be done by hand, but I'll also show you in the calculator. 10 through 14, or let me see. Problems like 10 through 13 are going to have at most one answer. Problems like 14 through 16 could have 0 through 2 answers. Just kind of a little side note. Okay, so 12. Well, okay, so 10 through 13, since they can have only at most one answer, they're not that bad to do by hand. The ones that can have more than 2 answers, you're going to square and do some stuff and get a quadratic. So that's why I'm separating these two categories. Because the 14 through 16 take a little bit more time to work through. It's not that bad to do by hand. It takes a lot of time. So if you're kind of pressed for time on the exam, you don't want to have to worry about 14 through 16 by hand. Okay. So, number 12. Square. Square leaves me what's inside. X plus 6. Negative 1 minus 6x. So I have more x's on the left side. So I'm going to move all my x's to the left side. So I move my constants to the other side. So it gives me 7x equals negative 7. So divide by 7, and you get that x is negative 1. When I square both sides, I've got to be really, really careful about that 3. That 3 is getting squared as well. So when I square the left side, that's no biggie. I get 7 minus 2x. On the right side, I get 9 times negative 2 minus 3x. So I'm going to distribute the 9 through, and that gives me 7 minus 2x equals negative 18 minus 27x. And I have more x's on the left side, so I'm going to add 27x over, subtract 7, that gives me 25x equals negative 25, divide by 25, and I get x is negative 1. If you're going to solve these by hand, make sure that you're going back and checking, like I haven't been doing. But, because you could have an extraneous solution, and that's going to be on the test. It's going to ask you if you have an extraneous solution. So make sure you're going back and checking. If you had negative 1 here, that'd be 7 plus 2 is 9. So the square root of 9 would be 3. And then the right side, let me see what I'll have. Square root, plus 3. So negative 2 plus 3 would be 1. So the square root of 1 is 1. So 3 equals 3, yes. On number 12, negative 1 is going to be square root of 5, which I don't care what the value is, as long as the right side is also the square root of 5. So if negative 1 plus 6, that's square root of 5 as well. So that works.